Have you ever wondered how scientists determine the size of polymer molecules? Not by looking at them, because they're far too small. Instead, they use a powerful technique called Gel Permeation Chromatography, or GPC. This method helps us understand something extremely important: the molecular weight distribution of polymers. And this information directly controls the strength, durability, and performance of materials we use every day. In this presentation, we will explore the basic principle behind GPC and understand how this fascinating technique works. Polymers are not uniform. They are made of chains, and these chains vary in length. Some chains are long, some are short, and this variation affects the material's properties. For example, chain length affects strength, toughness, and elasticity. This is why molecular weight distribution is so important. GPC plays a critical role in quality control, ensuring consistency in plastics, coatings, and other polymer products. It is also essential in critical industries, such as drug delivery and biomedicine, where precise molecular size can affect performance and safety. The core principle of GPC is separation based on hydrodynamic volume, which means the effective size of molecules in solution. Inside the GPC column, there are porous beads that act like microscopic sponges. These beads contain many tiny holes or pores. Small molecules can enter these pores and travel through them. Large molecules cannot enter most of the pores and are excluded. Because of this difference in pathways, large molecules move faster through the column. As a result, large molecules exit first and small molecules exit last. This is why the technique is also known as Size Exclusion Chromatography. Now, let's look at the main components of a GPC instrument. First, we have the solvent and pump. The solvent carries the sample through the system, and the pump pushes it at a constant flow rate. Next is the injector, which introduces the polymer sample into the flowing solvent. The sample then enters the column, which is the heart of the system. This is where the separation based on size takes place. Finally, the separated molecules reach the detector. The detector records the signal, which is later used to calculate molecular weight. Inside the column, molecules separate based on their size. Large molecules cannot enter the pores, so they take the shortest path and elute first. Medium-sized molecules enter some pores and take a slightly longer path, so they elute in the middle. Small molecules enter many pores. They take the longest and most complex path. As a result, they elute last. This difference in elution time allows us to separate molecules according to size. Once the molecules are separated, we need to calculate their molecular weight. This is done using a calibration curve. First, we run standard polymers with known molecular weights. We record their elution volumes. Then, we plot a calibration curve. When we run an unknown sample, we compare its elution volume to this curve. This allows us to calculate important parameters such as number average molecular weight, or Mn, weight average molecular weight, or MW, and polydispersity index, also called PDI. These values help us fully understand the polymer. Let's look at a real industrial example. An industry was manufacturing HDPE pipes, but the pipes were failing in the field. To investigate the problem, they used GPC. The analysis revealed that the polymer chains were shorter than specified. This explained why the pipes were weaker. Because of GPC, they identified the root cause. They prevented defective shipments and saved $2.3 million in recall costs. This shows how powerful and important GPC is in real-world applications. If you are working with GPC in a laboratory, proper handling is very important. First, Always filter your sample using a 0.45 micrometer filter. Dust particles can damage the column, which is very expensive. Second, always use the correct solvent. Using the wrong solvent can damage the column or affect the polymer structure. Following these precautions ensures accurate results and longer column life. GPC offers several advantages. It provides complete molecular weight distribution data. It is reliable and non-destructive. This means the sample is not destroyed during analysis. However, it also has some limitations. It requires calibration using standards. And it cannot distinguish between molecules of the same size, but different shapes. Despite these limitations, GPC remains the gold standard for polymer characterization. Gel Permeation Chromatography works on a simple principle, separation by size. But the information it provides is extremely powerful. It helps scientists understand polymer structure, ensure product quality, and solve industrial problems. From basic research to industrial production, GPC plays a vital role. It truly demonstrates how a simple principle can produce powerful results.